Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Pine. A pine is any conifer tree or shrub in the genus Pinus of the family Pinaceae. Pinus is the sole genus in the subfamily Pinodi. The World Flora Online, created by the Royal Botanic Gardens, Kew, and Missouri Botanical Garden, accepts 187 species names of pines as current, together with more synonyms. The American Conifer Society, ACS, and the Royal Horticulture Society accept 121 species. Pines are commonly found in the Northern Hemisphere. Pine may also refer to the lumber derived from pine trees. It is one of the more extensively used types of lumber. The pine family is the largest conifer family, and there are currently 818 named cultivars or trinomials recognized by the ACS. Description: Pine trees are evergreen coniferous resinous trees, or rarely shrubs, growing 3 to 80 meters tall, with the majority of species reaching 15 to 45 meters tall. The smallest are Siberian dwarf pine and Potosi pinyon, and the tallest is an 81.8 meter tall ponderosa pine located in southern Oregon's Rogue River Siskiyou National Forest. Pines are long-lived and typically reach ages of 100 to 1,000 years, some even more. The longest-lived is the Great Basin bristlecone pine. One individual of this species, dubbed Methuselah, is one of the world's oldest living organisms at around 4,800 years old. This tree can be found in the White Mountains of California. An older tree now cut down was dated at 4,900 years old. It was discovered in a grove beneath Wheeler Peak, and it is now known as Prometheus, after the Greek immortal. The spiral growth of branches, needles, and cone scales may be arranged in Fibonacci number ratios. The new spring shoots are sometimes called candles. They are covered in brown or whitish bud scales and point upward at first, then turn green and spread outward. These candles offer foresters a means to evaluate fertility of the soil and vigor of the trees. Bark. The bark of most pines is thick and scaly, but some species have thin, flaky bark. The branches are produced in regular pseudo-whorls, actually a very tight spiral, but appearing like a ring of branches arising from the same point. Many pines are uninodal, producing just one such whorl of branches each year, from buds at the tip of the year's new shoot, but others are multinodal, producing 2 or more whorls of branches per year. Foliage. Pines have 4 types of leaf. Seed leaves on seedlings are borne in a whorl of 4 to 24. Juvenile leaves, which follow immediately on seedlings and young plants, are 2 to 6 centimeters long, single, green, and often blue-green, and arranged spirally on the shoot. These are produced for 6 months to 5 years, rarely longer. Scale leaves, similar to bud scales, are small, brown, and not photosynthetic, and arranged spirally like the juvenile leaves. Needles, the adult leaves, are green and bundled in clusters called fascicles. The needles can number from 1 to 7 per fascicle, but generally number from 2 to 5. Each fascicle is produced from a small bud on a dwarf shoot in the axil of a scale leaf. These bud scales often remain on the fascicle as a basal sheath. The needles persist for 1.5 to 40 years, depending on species. If a shoot's growing tip is damaged, e.g., eaten by an animal, the needle fascicles just below the damage will generate a stem-producing bud, which can then replace the lost growth tip. Cones. Pines are monoecious, having the male and female cones on the same tree. The male cones are small, typically 1 to 5 centimeters long, and only present for a short period, usually in spring, though autumn in a few pines, falling as soon as they have shed their pollen. The female cones take 1.5 to 3 years, depending on species, to mature after pollination, with actual fertilization delayed 1 year. At maturity, the female cones are 3 to 6 centimeters long. Each cone has numerous spirally arranged scales, with 2 seeds on each fertile scale. The scales at the base and tip of the cone are small and sterile, without seeds. The seeds are mostly small and winged, and are anemophilous when dispersed, but some are larger and have only a vestigial wing, and are bird dispersed. Female cones are woody and sometimes armed to protect developing seeds from foragers. At maturity, the cones usually open to release the seeds. In some of the bird-dispersed species, for example white bark pine, the seeds are only released by the bird breaking the cones open. In others, the seeds are stored in closed cones for many years until an environmental cue triggers the cones to open, releasing the seeds. This is called serodony. The most common form of serodony is pyrrhescence, in which a resin binds the cone shut until melted by a forest fire. Taxonomy. Pines are gymnosperms. The genus is divided into 2 subgenera based on the number of fibrovascular bundles in the needle. The subgenera can be distinguished by cone, seed, and leaf characters. Pinus, the yellow or hard pine group, generally with harder wood and 2 or 3 needles per fascicle. The subgenus is also named diploxylon on account of its 2 fibrovascular bundles. Strobus, the white or soft pine group. Its members usually have softer wood and 5 needles per fascicle. The subgenus is also named haploxylon on account of its 1 fibrovascular bundle. Phylogenetic evidence indicates that both subgenera have a very ancient divergence from one another, having diverged during the late Jurassic. Each subgenus is further divided into sections and subsections. Many of the smaller groups of Pinus are composed of closely related species with recent divergence and history of hybridization. This results in low morphological and genetic differences. This, coupled with low sampling and underdeveloped genetic techniques, has made taxonomy difficult to determine. Recent research using large genetic datasets has clarified these relationships into the groupings we recognize today. Distribution and habitat. Pines are native to the northern hemisphere and to a few parts from the tropics to temperate regions in the southern hemisphere. Most regions of the northern hemisphere host some native species of pine. One species crosses the equator in Sumatra to 2 degrees south. In North America, various species occur in regions at latitudes from as far north as 66 degrees north to as far south as 12 degrees north. Pines may be found in a very large variety of environments, ranging from semi-arid desert to rainforests, from sea level up to 5,200 meters, from the coldest to the hottest environments on Earth. They often occur in mountainous areas with favorable soils and at least some water. Various species have been introduced to temperate and subtropical regions of both hemispheres, where they are grown as timber or cultivated as ornamental plants in parks and gardens. A number of such introduced species have become naturalized, and some species are considered invasive in some areas and threaten native ecosystems. Ecology. Pines grow well in acid soils, some also on calcareous soils. Most require good soil drainage, preferring sandy soils, but a few, e.g. lodgepole pine, can tolerate poorly drained wet soils. A few are able to sprout after forest fires, e.g. Canary Island pine. Some species of pines, e.g. bishop pine, need fire to regenerate, and their populations slowly decline under fire suppression regimens. Pine trees are beneficial to the environment since they can remove carbon dioxide from the atmosphere. Although several studies have indicated that after the establishment of pine plantations in grasslands, there is an alteration of carbon pools, including a decrease of the soil organic carbon pool. Several species are adapted to extreme conditions imposed by elevation and latitude, e.g. Siberian dwarf pine, mountain pine, white bark pine, and the bristlecone pines. The pinyon pines and a number of others, notably Turkish pine and gray pine, are particularly well adapted to growth in hot, dry, semi-desert climates. Pine pollen may play an important role in the functioning of detrital food webs. Nutrients from pollen aid detritivores in development, growth, and maturation, and may enable fungi to decompose nutritionally scarce litter. Pine pollen is also involved in moving plant matter between terrestrial and aquatic ecosystems. Wildlife. Pine needles serve as food for various Lepidoptera, butterfly, and moth species. Several species of pine are attacked by nematodes, causing pine wilt disease, which can kill some quickly. Some of these Lepidoptera species, many of them moths, specialize in feeding on only one or sometimes several species of pine. Besides that, many species of birds and mammals shelter in pine habitat or feed on pine nuts. The seeds are commonly eaten by birds such as grouse, crossbills, jays, nuthatches, siskins, and woodpeckers, and by squirrels. Some birds, notably the Clark's nutcracker and pinyon jay, are of importance in distributing pine seeds to new areas. Pine needles are sometimes eaten by the symphidine species pine sawfly and goats. Lumber and construction. Pines are among the most commercially important tree species valued for their timber and wood pulp throughout the world. In temperate and tropical regions, they are fast-growing softwoods that grow in relatively dense stands, their acidic decaying needles inhibiting the sprouting of competing hardwoods. Commercial pines are grown in plantations for timber that is denser and therefore more durable than spruce. Pine wood is widely used in high-value carpentry items such as furniture, window frames, paneling, floors, and roofing, and the resin of some species is an important source of turpentine. Because pine wood has no insect or decay-resistant qualities after logging, in its untreated state it is generally recommended for indoor construction purposes only, indoor drywall framing, for example. For outside use, pine needs to be treated with copper azyl, chromated copper arsenate, and other suitable chemical preservative. Ornamental uses. Many pine species make attractive ornamental plantings for parks and larger gardens, with a variety of dwarf cultivars being suitable for smaller spaces. Pines are also commercially grown and harvested for Christmas trees. Pine cones, the largest and most durable of all conifer cones, are craft favorites. Pine boughs, appreciated especially in wintertime for their pleasant smell and greenery, are popularly cut for decorations. Pine needles are also used for making decorative articles such as baskets, trays, pots, etc. And during the U.S. Civil War, the needles of the longleaf pine, Georgia pine, were widely employed in this. This originally Native American skill is now being replicated across the world. Pine needle handcrafts are made in the US, Canada, Mexico, Nicaragua, and India. Pine needles are also versatile and have been used by Latvian designer Tamara Orjola to create different biodegradable products, including paper, furniture, textiles, and dye. Farming. When grown for sawing timber, pine plantations can be harvested after 25 years, with some stands being allowed to grow up to 50, as the wood value increases more quickly as the trees age. Imperfect trees, such as those with bent trunks or forks, smaller trees, or diseased trees, are removed in a thinning operation every 5 to 10 years. Thinning allows the best trees to grow much faster because it prevents weaker trees from competing for sunlight, water, and nutrients. Young trees removed during thinning are used for pulpwood or are left in the forest, while most older ones are good enough for saw timber. A 30-year-old commercial pine tree grown in good conditions in Arkansas will be about 0.3 meters in diameter and about 20 meters high. After 50 years, the same tree will be about 0.5 meters in diameter and 25 meters high, and its wood will be worth about 7 times as much as the 30-year-old tree. This, however, depends on the region, species, and silvicultural techniques. In New Zealand, a plantation's maximum value is reached after around 28 years, with height being as high as 30 meters and diameter 0.5 meters, with maximum wood production after around 35 years, again depending on factors such as side stocking and genetics. Trees are normally planted 3 to 4 meters apart, or about 1,000 per hectare. Food and nutrients. The seeds, pine nuts, are generally edible. The young male cones can be cooked and eaten, as can the bark of young twigs. Some species have large pine nuts, which are harvested and sold for cooking and baking. They are an essential ingredient of pesto alla genovese. The soft, moist, white inner bark, cambium, beneath the woody outer bark is edible and very high in vitamins A and C. It can be eaten raw in slices as a snack or dried and ground up into a powder for use as an ersatz flour or thickener in stews, soups, and other foods such as bark bread. Adirondack Indians got their name from the Mohawk Indian word aterutaks, meaning tree eaters. A tea is made by steeping young green pine needles in boiling water, known as tallstrand in Sweden. In Eastern Asia, pine and other conifers are accepted among consumers as a beverage product and used in teas as well as wine. In Greece, the wine retsina is flavored with Aleppo pine resin. Pine needles from Pinus densiflora were found to contain 30.54 milligrams of proanthocyanins when extracted with hot water, comparative to ethanol extraction resulting in 30.1 milligrams. Simply extracting in hot water is preferable. In traditional Chinese medicine, pine resin is used for burns, wounds, and dermal complaints. Culture. Pines have been a frequently mentioned tree throughout history, including in literature, paintings, and other art, and in religious texts. Literature. Writers of various nationalities and ethnicities have written of pines, among them John Muir, Dora Sigerson Shorter, Eugene Field, Bai Juyi, Theodore Winthrop, and Reverend George Allen. Religious texts. Pine trees as well as other conifers are mentioned in some verses of the Bible depending on the translation. In the book of Nehemiah 8:15, the King James Version gives the following translation: "And that they should publish and proclaim in all their cities and in Jerusalem, saying, Go forth unto the mount, and fetch olive branches and pine branches, and myrtle branches and palm branches, and branches of thick trees to make booths, as it is written. However, the term here in Hebrew means oil tree, and it is not clear what kind of tree is meant. Pines are also mentioned in some translations of Isaiah 60:13, such as the King James. The glory of Lebanon shall come unto thee, the fir tree, the pine tree, and the box, together to beautify the place of my sanctuary, and I will make the place of my feet glorious. Again, it is not clear what tree is meant, and other translations use pine for the word translated as box by the King James. Some botanical authorities believe that the Hebrew word berosh, which is used many times in the Bible, designates halepensis, or in Hosea 14:8, which refers to fruit, Pinus pinea, the stone pine. The word used in modern Hebrew for pine is oren, which occurs only in Isaiah 44, verse 14. But two manuscripts have cedar, a much more common word. Chinese culture. The pine is a motif in Chinese art and literature, which sometimes combines painting and poetry in the same work. Some of the main symbolic attributes of pine in Chinese art and literature are longevity and steadfastness. The pine retains its green needles throughout all the seasons. Sometimes the pine and cypress are paired. At other times, the pine, plum, and bamboo are considered as the three friends of winter. Many Chinese artworks and/or literature, some involving pines, have been done using paper, brush, and Chinese ink. Interestingly enough, one of the main ingredients for Chinese ink has been pine soot. Tree of Peace. The Iroquois Tree of Peace finds its roots in a man named Decanawada, the peace giver. The legend surrounding his place amongst the Iroquois is based in his role in creating the Five Nations Confederacy, which consisted of the Mohawks, Oneidas, Onondagas, Cayugas, and Senecas, and his place as a cultural hero to the Haudenosaunee Nation, commonly known in Western culture as Iroquois. The official title of the Confederacy is Kayanera Koa, the Great Place, as described by Paul A. Wallace. It is also known as Kanancioni, the Longhouse, a term that describes both its geographical extent and its constitutional form. The myths and legends surrounding Decanawada have the roots in the oral histories that followed many Native American tribes throughout their histories. A political reality with mythic proportions, the association of Decanawada and the Tree of Peace is central to the Haudenosaunee. Decanawada, on his travels to bring the warring nations together, talked only of peace, friendship, and unity. As Barbara Graymont states, Decanawada's ideas and actions were noticeably separating him from his people. The Wyandots could not understand a man who loved peace more than war. The great peace associated with Decanawada came with three parts: the good word, which is righteousness in action, bringing justice for all; health, which is a sound mind and a sound body, bringing peace on earth; power, which is the establishment of civil authority, bringing with it the increase in spiritual power in keeping with will of the Master of Life. The creation of the Five Nations was given a symbol by Decanawada that would symbolize the newly accepted peace and unity of the Five Nations. The symbol chosen for the League of the Five Nations was the great white pine tree, the tree of the great long leaves. The three had four symbolic roots: the great white roots of peace, spreading north, east, south, and west. If any other nation ever wished to join the League, it would have to follow the white roots of peace to the source and take shelter beneath the tree. Atop the tree, he placed an eagle to scream out a warning at the approach of danger. He symbolically planted the tree in the lands of the Onondagas, the place of the Gra. The Confederate lords, or peace chiefs, would sit beneath it and be caretakers of the great peace. This tree of peace became the symbol of solitude among the chiefs. The creation of the tree of peace figuratively gave the chiefs the ability never to die because their chiefly titles would be passed down to their successors forever. In this way, the League of Nations would always be kept alive. The Tree of Peace has its roots in the creation of the League of Five Nations, but its place within the Haudenosaunee culture is crucial to its role in the continuation of its existence to this day. As A.C. Parker states, the Tree of Peace is an important symbol of people in Iroquois tradition and in the historical record of diplomacy between the Iroquois and Westerners. Weapons would be buried under a tree to seal a peace agreement. A tree might even be uprooted to create a cavity for the weapons. The replanted tree on top would become a tree of peace. This concept of creating a new tree of peace is rooted in the tradition created by Dekanawada's initial ceremony for the tree of peace. The roots will stretch in all directions, and it is upon these roots our future brothers and sisters must forge their own peace and continue to the path we have created. As Barbara Graymont states, this transformation of the historical account shows the extent to which these events had taken on a sacred character for the Iroquois. The exact details were not nearly as important to them as testifying to the authenticity of their confederacy and the significance of what their ancestors had done for them. In establishing unity and preserving their nationhood, the ancestors had provided for all time a purpose and a way of life for the people of the extended lodge. Its characteristic bundles of 5 needles became the symbol of the 5 nations joined together as one. According to Haudenosaunee tradition, the great law of peace ended the ancient cycle of enmity and continuous conflict between the separate tribes and united them into the Iroquois Confederacy that made them into the most powerful force in North America until the rapid expansion of European colonization in the 18th century. Pine cypress forest. Pine cypress forest is a type of mixed conifer woodland in which at least one species of pine and one species of cypress are present. Such forests are noted in several parts of the world but are particularly well studied in Japan and the United States. Ecology. A quality of these mixed conifer forests is the mutualistic relationship between pine and cypress trees. In Japanese pine-cypress forests, pine stumps have been found to help stimulate the growth and germination of cypress trees. Cypress trees are extremely sensitive to pH and prefer more acidic soils. Decaying pine stumps have a lower pH than surrounding soils. It is believed that this is the main factor influencing the increased prevalence of cypress seedlings. Analysis of evapotranspiration on pine and cypress wetlands found that both tree types are sensitive to changes in ambient temperature, but pines are more sensitive to changes in humidity. This difference in vulnerabilities could contribute to overall forest resiliency. Forest management. Like many mixed forest types, human forest management can impact the structures of pine-cypress forests. A study based in Taiwan used computer modeling to determine the stand density index for pine-cypress forests. This helps to measure interspecies relationships within forests, including species density, competition, and tree development. This is helpful for informing future management practices by maintaining a more current understanding of forest dynamics. Because both tree types can be very sensitive to changes in forest hydrology, additional management is necessary beyond density monitoring. Contentious management of flooding and drainage was shown to improve the health of both pine and cypress trees in a mixed ecosystem. Global occurrences. Japan. Pine-cypress forests can be found in much of central Japan, a heterogeneous landscape consisting of pine-oak forests, timber plantations, and cypress groves help to maintain this forest structure. United States. California. California occurrences of pine cypress forest are typically along Pacific coastal headlands. Understory species of these California pine cypress forests include salal and western poison oak. Florida. Many of the Florida occurrences of pine cypress forest are in swampy areas such as the Everglades. Pine barrens. Pine barrens, pine plains, sand plains, or pineland areas occur throughout the U.S. from Florida to Maine, as well as the Midwest, West, and Canada, and parts of Eurasia. Perhaps the most well-known pine barrens are in the New Jersey pine barrens. Pine barrens are generally pine forests in otherwise barren and agriculturally difficult areas. Such pine forests often occur on dry, acidic, and fertile soils, which also include grasses, forbs, and low shrubs. The most extensive pine barrens occur in large areas of sandy glacial deposits, including outwash plains, lake beds, and outwash terraces along rivers. Description: Botany. The most common trees are the jack pine, red pine, pitch pine, blackjack oak, and scrub oak. A scattering of larger oaks is not unusual. The understory includes grasses, sedges, and forbs, many of them common in dry prairies, and rare plants such as the sand plain Gerardia. Plants of the heath family such as blueberries and bearberries, and shrubs such as prairie willow and hazel are common. These species have adaptations that permit them to survive or regenerate well after fire. Fauna. Pine barrens support a number of rare species, including Lepidoptera such as the Carner blue butterfly and the barren's buck moth. Fire ecology. The American Indians used fire to maintain such areas as rangeland. Suppression of wildfires has allowed larger climax forest vegetation to take over in most one-time barrens. Barrens are dependent on fire to prevent invasion by less fire-tolerant species. In the absence of fire, barrens will proceed through successional stages from pine forest to a larger climax forest, such as oak-hickory forest. However, temperatures in a white pine forest on Long Island were high enough to destroy the pine cones, which led to a slow recovery of the pine forest that varied depending on the availability of seedlings and the spatial variability in the conditions in the soil encountered by the seedlings.